So today we are going to look at evaluating nth roots and solving equations using nth roots. And I'll talk about that word root in a minute. It has been something that we've looked at before. We're also going to look at rational exponents and what it means to have a rational exponent. So the first two things we kind of have been talking about, but the nth root of a means I would have, exactly as it says. Remember, we looked at that little index, that n. So if it says nth root of a, I would have this root and the n on the radical symbol, and then the a underneath. So that's the nth root of a. There is a formal definition that says b to the n equals a if b is an nth root of a. So that's what like a formal definition would be. And then we said the index of the radical is the actual n. That's called the index. So a third root, a fourth root, a fifth root. All right, so here's where it gets a little weird. It says the real nth roots of a number. This is like a double meaning word right here. So a root is when you take the square root of something or the cube root of something or the fourth root of something. But a root is also a solution when you're solving for x. So it's like a word with a double meaning. So a root is the same thing as also a solution when solving for x. It's also an x-intercept. All those words mean the same thing. And we talked about that at the end of chapter 5. So a root is a solution if you're solving for x. All right, so yes, we're talking about taking a root of a number, but we're also going to be talking about solving for x. So there is a little chart down below that talks about having an nth root or an even root versus an odd root, or if the index is even versus the index being odd. So remember, n is the index. It says let it be an integer greater than 1, and let a, that is italicized, but it's hard to see, be a real number. So we're talking about a being the number underneath and the index being bigger than 1. If it is even, and this is important here, so a square root, a fourth root, a sixth root. So when that index is even, then there are 3 conditions underneath that exist or that happen. And this goes back to chapter 4 when we started solving for x squared. So it says if a is less than 0, then there is no nth root. So if I take the square root of -9, a is -9. That's my a. A is the number underneath. Can you take the square root of -9? No. Because when you're taking a square root, you're saying there are 2 exact numbers that multiply together to be the value underneath the square root. And -9 doesn't have 2 exact answers. We learned in chapter 4 that a negative number under a square root gives us an imaginary value. So that's why it says it has no real nth roots, because this is equal to an imaginary number. And that's from chapter 4. Imaginary numbers happen when you take the square root or any even root of a number. So I could take the fourth root or the sixth root of any negative number, and it gives me an imaginary value. All right, the next part. if you take the nth root of 0, you get one answer. What is the 4th root of 0? What is the 6th root of 0? The 10th root of 0, the 20th root of 0. Malachi, what do you think? The 4th root of 0, the 6th root of 0. 0. So anytime you're taking any even root of 0, it's still going to be 0. And then the last one is what we talked about when you were solving for x in chapter 4. If you take the square root of a number, so let's go back and think about chapter 4. Chapter 4, we were solving for x squared. And we took the square root of x squared to get x by itself. Faith, what did we say the square root of 9 was if you're solving for x squared? What else did we say it was? Besides just 3. What else makes 9? Besides 3 times 3. 9 times 1. But what else? Remember we said that plus or minus anytime we take a square root. So positive 3 times positive 3 makes 9, but negative 3 times negative 3 also makes 9. So anytime you take an even root, a square root, a 4th root, a 6th root, there must be a plus or minus in front of that radical. So I must have a plus or minus value in front. And that answer is going to be plus or minus a, and then whatever my radical ends up being, 1 over n. So I would evaluate it and get a number there. But it's going to be a plus or minus. That's the biggest thing I need you to think about. So think about x squared equaling 9. When I take the square root, 3 and 3 make 9, but negative 3 and negative 3 also make 9. And that works with any even value, even root, because you're multiplying pairs together, and that's how you get positive values. All right, so if we look at the other side, you are allowed to take odd values of negative numbers. So if I have the cube root of negative 8, my answer is going to be negative 2. Because negative 2 times negative 2 times negative 2 makes negative 8. So when you take an odd root of a negative number, your answer remains negative. So you're going to have a negative answer of A, like my negative 2. Any odd root of 0 is still 0. The 3rd root of 0, the 5th root of 0, the 11th root of 0, that's still going to be 0. And then when I look at it, having a positive number underneath, my answer is going to be positive. So when it's an odd root, I don't get a plus or minus. Because when I multiply 3 things together or 5 things together, the value, it doesn't have that pair to pull it back together. So the value remains positive or the value remains negative. So if it's negative underneath, the answer is negative. If it's positive underneath, the answer is positive. So we're going to look at the 2 examples underneath. It says find the indicated real nth root of A, or roots pluralized. So n is 3 and A is negative 64. So remember, this gets written as our index, and then the radical, and then the number underneath, the radicand. So this is going to be 3 negative 64 underneath the radical. What is the cube root of negative 64? Well, this is what we've been working on. We just haven't been writing it with this specific notation of kind of given the information and you have to change it to a radical. So Riley, what's the cube root of negative 64? Negative 4. This is odd, so my answer is going to remain negative. If it starts out negative, it remains negative. So if we look at B, the n is 6 and the a is 729. So we have the 6th root of 729. Well, 6 is even. 729 is a positive number underneath. What is the 6th root of 729? Remember that little sheet that I gave you, that common power sheet, that's still going to be very beneficial for you to use. Jordan, do you remember what the 7th root of 729 is? It is 3. And then because the index is even, I need a plus and a minus answer. So anytime that we would be solving, if it says find the indicated real roots, a root is an answer to an equation. I know this isn't set up as an equation, but we're still finding the answer. So I need that plus or minus there. Questions? All right, so the other thing we're going to look at today is something called a rational exponent. So this first part here are the evaluating nth roots part. Now we're going to try and use rational exponents. So we're going to have an exponent, but it's going to be in a rational form. A rational number is a fraction. So an integer is a positive or negative whole number. 1, 2, 3, -1, -2, -3. A rational number is anything that can be written as a fraction. So 0.5 is 1/2. 0.75 is 3/4. So any number that can be written in fraction form is called a rational number. We're going to look at rational exponents. So this says let a to the 1 over n be an nth root of a. And I'm just going to stop there. So right now they're saying the nth root of a can be written as an exponent of a to the 1 over n. So a radical can be written as an exponent. That means the cube root of a can be written as a to the 1 over 3. So a radical can change to exponential form by taking the index and putting it underneath the number 1. So if I had the square root of 7, I could write that as 7 to the 1 over what? What number would it be if you're taking the square root? Okay, 2. Remember, the square root, there's a little implied 2 sitting on the radical. So any index can be written as an exponent. So if it was a 7, I would write 1 over 7. If it was an 8, I would write 1 over 8. So if we had the 8th root of a, I would say a to the 1/8. Sorry, that was underneath, was supposed to be an a. There we go. So we're going to expand that a little bit and say, well, all of my fractions don't have to have a 1 on top. I have other fractions that are beyond 1/3, 1/2, 1/8. And that's what this little part here is talking about with rational exponents. So let a to the 1 over n be the nth root of a, and m be a positive integer. So we just talked about 1 over a being an nth root of a. So then it takes it a step further and it says, what happens if I have a to the m divided by n? We can change this back to a radical to help us simplify. The way it gets changed to a radical is by taking the index, which is the n, and placing it back on the radical. So the denominator is your index. So that n is our index. The numerator is going to be the exponent. So when I take that a and write it underneath, it has the exponent of m. That can be the same as the nth root of a all raised to the m power. And we did some problems like that where we were applying that property. That's the power property that we applied last Tuesday when we started doing the radicals. So the index is the denominator. The exponent is the numerator of our rational exponent. Now, the next one has a negative value. So we have a to the negative m over n. Just a little reminder, what happens if you had a to the negative 2? When we had a negative exponent in chapter 5, what did a negative exponent do? How did it change? How did it simplify? Does anybody remember at home? How did you simplify a to the negative 2? Faith, do you remember? Close. You put it as 1 over. Brooke, were you going to answer? I don't know who it was.
Oh, yes, I was. It would be 1 over a squared.
Yeah, and Faith, I think you were like on the right track. So it would be 1 over a squared. The 2 would be positive, which I think that's the track you were thinking as well, Faith. So if I have a negative exponent, this, to make it a positive exponent, I have to take it and place it underneath the value of 1. So the whole thing becomes a fraction. And then my exponent becomes positive. So a negative exponent is always placed under the number 1 to make it a positive exponent. And then I could take it a step further and write it in radical form. So I could then say 1 over the nth root of a to the m. Or 1 over the nth root of a to the m as well. So notice that m can be attached to the number, or it could be applied outside. Does anybody have questions? Anybody at home have questions? So our next group of examples just wants us to evaluate. It doesn't say find the nth root. It just says to us to evaluate the problem. So we're going to try and evaluate these rational exponents. The first one we have is 8 to the negative 4/3. So before I do anything with the fraction, I have to worry about the negative. If the exponent is negative, I need to take that and place it underneath the number 1. So it still is a 4/3, but now it's 1 over 8 to the 4/3. So that's the first step. The second step is going to be to change the way this is written, because evaluate means break it down and simplify. Well, as a rational exponent, we can't really simplify it in this form. That's why we change it to a radical. So we're going to keep the 1, and then we're going to change the way we write 8 to the 4/3 by writing it as a radical. So our index is the denominator. So my index is going to be 3. And then I have the 8. The exponent is 4. Questions about changing the way that's written? I'm going to rewrite this one more time, keeping the 8, but pulling the 4 outside. And the reason I did that was because I want to take the cube root of 8. Our goal is to simplify. Simplify means to break down. So Riley, what is the cube root of 8? 2. So this becomes 2. And then Riley, I can take 2 to the 4th and make it 16. Yeah. Now I have simplified it and I have made it an actual number. So it no longer is a radical. It no longer is a exponent, but it's actually the number 1/16. So we changed it to a fraction because it had a negative exponent. We wrote it as a radical, and then we started simplifying it by simplifying the radical and then applying the exponent. Questions? So let's try number 2, or letter B, not really number 2. So we have 81 to the 1/4. So rewrite it first. The 4 is the n. That's my index. 81 is still my radicand. So that base number is going to be the number underneath the radical. And then we have the 4th root of 81. Malachi? Just 3. Yeah. All right, let's try the next one. -8.
Miss Kane, would it be plus or minus 3?
You know what? That's where it becomes tricky. So the difference in the directions, here it says to find the roots, which means you're technically solving for x, and that's when it's plus or minus.
Oh, okay.
This just, I know it's tricky. This just asks you to evaluate, and when you're evaluating, you're not truly solving for anything, you're just breaking the given number down. So it's like, sometimes you do, sometimes you don't. You're gonna have to look at the directions, but that's a really good question to kind of think about. So if it says find the roots, like my question 3 underneath says find the roots again, that's when we worry about the plus or minus. If it says to evaluate, then it's just that value that's given. Does that make sense? It's kind of like sometimes you do, sometimes you don't, depending on what the directions are asking.
Yeah, that makes sense.
Okay, good to bring that up. Nice job thinking on it. All right, so number C, or letter C, we have -8 to the 4/3. Faith, is 4/3 negative? No. So what would this look like if you rewrite it, Faith? Yeah. So the 8 is negative, but not the exponent, so the 8 goes underneath. What is the cube root of -8, Faith? And then -2 to the 4th. Do you know what that is? Yeah. So you're taking -2, -2, -2, -2, which is 16. Questions? So there's one more like this one. See if you can do letter D. So it has a negative exponent. Watch that negative exponent. Rewrite it. So the first step would be to write it as a positive exponent and then change it to exponential form. So the denominator is the index. The numerator becomes the exponent. And notice I'm always writing that exponent on the outside. So Riley, the 5th root of 32 is, and then 2 squared becomes 4. So we're not making anything decimals. We're keeping it all exact as fractions. That number 1 is on the top because our exponent was negative. But we're not creating a decimal value, keeping it exact. So before we do the last group of problems, does anyone have questions so far on simplifying these exponents? So an exponent that's a fraction can really be written as a square root. So square roots or any kind of radical is really an exponent as well. So they can be written 2 different ways. So the last group of problems that we're going to look at today want us to solve the equation. I mean, pretty much the whole goal of algebra is to solve for x. So we're going to try and solve for x. It says by using nth roots. So when you're solving for x, This is when we have to think about, is it a plus or minus answer? Because we're physically solving for the x in the equation. So the first problem, 2x to the 6th equals 1,458. Think about the steps of solving an equation. Jordan, what would you typically do first to solve this equation? Yeah, just because it says x to the 6th doesn't change the steps or the process of isolating x. Wherever x is, we're going to isolate it. Do you know what that is, Jordan? 700, you said 29, right? Yeah. All right. How do you think you would get rid of x to the 6th? So think about when we had x squared. I just had my x squared equals 9. How did we get rid of x squared? Because we want to do the same process to get rid of x to the 6th. Jordan, do you have an idea?
Would you? I'm sorry, I can't find the right words. Oh, find the root of it?
Yeah, you're going to find the root of it. Yeah, it says we're using nth roots. So we're going to take the 6th root of it. Just like I would take the square root. I know it is weird, the 6th root. So we're solving it using nth roots. So we're taking whatever that exponent is to get rid of it. I'm doing the opposite. I'm taking the root of it. So what is the 6th root of 729? Okay, 3. Now here, this comes back to what Brooke was saying. Brooke, what do we put with that 3? What do we place with the 3?
Plus or minus?
Yeah, we have to place a plus or minus because this time we are solving and our root is even. We weren't solving above, we were just evaluating. So in the directions of the homework tonight, if it says evaluate, it's whatever you're given. Is it positive or it means positive? Is it negative? Then it would be negative. But when you're solving, you got to remember that plus or minus because now we're actually associating this with a graph, an equation. So why don't you try letter B? Looks pretty similar. We got x to the 5th. Faith, 128 divided by 4. 32. And then we would take the 5th root. Yeah, nice job. You'll get used to saying it. It's a little weird at first. And the 5th root of 32 is 2. This number here is odd. And when it's odd, if it's positive, my answer is positive. If it's negative, my answer is negative. So my original problem was positive 32. My answer remains positive because it's an odd radical or an odd root. All right, C and D are a little different. Letter C, we have the quantity attached in parentheses x plus 4 cubed equals 12. Now think, we don't want to make this more complicated. Our goal is to break it down. So if you have a quantity cubed, how do you get rid of the cube? Or if I had a quantity squared, how did we get rid of the squared? And you want to make it simplified. Malachi, do you know? So we could multiply it, but that's going to make it bigger. It's going to expand it, and it's going to make us do a lot more work. How could I get rid of the cube? Anybody know how we could get rid of that cube part? It's going to be the same thing that we did above. So just because there's a quantity that x plus 4 is grouped together with the cube, we want to get rid of the cube part. So we're going to take the cube root of that whole quantity. Yes, we could multiply it all together, but that makes the problem bigger and it expands the problem. Our goal is to condense it. The material or the terms, the binomial inside, right now they're inside. They're grouped together. So if I do the opposite to the outside by taking the cube root of both sides, My radical and exponent cancel and just leave us with an x plus 4. On the other side, we have the cube root of 12. Now remember, we're trying to solve, so I'd have to subtract a 4, and then I'd have negative 4. It's a positive, and then root 13. So your homework again is 3 to 33 odd. You'll be working with mostly the first part of the notes that we did. You may have 1 or 2 questions that deal with equations, but we're going to do more of these equations on Wednesday as well. So have a fantastic day. I'll see you tomorrow.